and I think you'll find it rather interesting. Now, I'm going to assume that you know that sunspots, in the most basic terms, are dark spots on the sun's surface. That'll do for now. The ancient Chinese were the first to record observations of sunspots as early as the year 165. When later European astronomers wrote about sunspots, they didn't believe that the spots were actually on the sun. That's because of their belief at the time that the heavenly bodies, the sun, moon, stars, and planets, were perfect, without any flaws or blemishes. So the opinion was the spots were actually something else, like shadows of planets crossing the sun's face. And this was the thinking of European astronomers until the introduction of the telescope. Which brings us to our old friend Galileo. In the early 1600s, based on his observations of sunspots, Galileo proposed a new hypothesis. He pointed out that the shape of sunspots, well, the sunspots weren't circular. If they were shadows of the planets, they would be circular, right? So that was a problem for the prevailing view. And he also noticed that the shape of the sunspots changed as they seemed to move across the sun's surface. Maybe a particular sunspot was sort of square, then later it would become more lopsided, then later something else. So there's another problem with the shadow hypothesis, because the shape of a planet doesn't change. What Galileo proposed was that sunspots were indeed a feature of the sun, but he didn't know what kind of feature. He proposed that they might be clouds in the atmosphere, the solar atmosphere, especially because they seemed to change shape, and there was no predicting the changes. At least nothing Galileo could figure out. That random shape changing would be consistent with the spots being clouds. Over the next couple hundred years, a lot of hypotheses were tossed around. The spots were mountains, or holes in the solar atmosphere through which the dark surface of the sun could be seen. Then in 1843, an astronomer named Heinrich Schwabe made an interesting claim. Schwabe had been watching the sun every day that it was visible for 17 years, looking for evidence of a new planet. And he started keeping track of sunspots, mapping them so he wouldn't confuse them with any potential new planet. In the end, there was no planet, but there was evidence that the number of sunspots increased and decreased in a pattern that began repeating after 10 years. And that was a huge breakthrough. Another astronomer named Wolf kept track of the sun for an even longer period, 40 years actually. So Wolf did 40 years of research, and Schwabe did 17 years of research. I think there's a lesson there. Anyway, Wolf went through old records from various observatories in Europe and put together a history of sunspot observations going back about 100 years. From this information, he was able to confirm the existence of a pattern, a repeating cycle. But Wolf detected an 11-year cycle, not a 10-year cycle. 11-year cycles? Does that sound familiar to anyone? No? Well, geomagnetic activity. The natural variations in the Earth's magnetic field. It fluctuates in 11-year cycles. Well, we'll cover this later in the semester, but for now, well, scientists in the late 19th century were aware of geomagnetic cycles, so when they heard that the sunspot cycle was also 11 years, well, they just had to find out what was going on. Suddenly, everyone was doing studies of the possible relationship between the sun and the Earth. Did the sunspots cause the geomagnetic fields, or did the geomagnetic fields cause the sunspots? Or was there some other thing that caused both? And astronomers did eventually figure out what sunspots have to do with magnetic fields. Actually, they are magnetic fields. And the fact that sunspots are magnetic fields accounts for their dark appearance. That's because magnetic fields reduce the pressure exerted on the gases inside of them, making the spots cooler than the rest of the sun's surface. And since they're cooler, they're darker. We're going to start a study of sunspots today, and I think you'll find it rather interesting. Now, I'm going to assume that you know that sunspots, in the most